Okay, today we're going to talk about types of reactions, and I'm going to show you how to complete some synthesis, decomposition, and combustion reactions. Those are the easy ones, but you do need to kind of know the 5 types of reactions. It kind of helps you to complete them. Although, you guys, a lot of you being at home or using your notes to do this, you get a lot more help than people would have gotten in the past. So, first of all, synthesis reaction. Synthesis means to come together. So the general form for a synthesis reaction is when you have 2 or more, it could be more than that, reactants combined, everything combined together to form one thing. So that's synthesis reaction, and a decomposition reaction is exactly the opposite. In this case, if something is decomposing, it's breaking apart. In this case, we're showing it as being, a compound here breaking apart into 2 things, but it actually could be far more complicated. Like it could be a very, very large compound to break apart into 3 or 4 things. That would still be decomposing. Single replacement reactions, double replacement reactions, and combustion are very specific. So in a single replacement reaction, you always have an element that is replacing another element in a compound. And so in this case, this element is replacing that element. And there is a way to know, and we're going to show you how to know in complete single replacement reactions to know whether or not they occur by using what's called an activity series. And the bottom line is that this is a metal, it will replace a metal. If this is a non-metal, it will replace the non-metal. And so that's how you'll know, how to put them together on the other side of the equation. So if that was a metal, and this would be a metal and a non-metal, so this one's going to kick out that one. And so now you end up, this metal takes its place, and it kicked the other metal out. And like I say, if this was a non-metal, it would kick out the other one. So that's a single replacement reaction. You got an element, a compound on both sides. Double replacement reaction, notice you got a compound, you get 2 compounds on both sides. What's actually happening there, these are always ionic compounds, so this would be a metal, and this would be a non-metal, or polyatomic, because all the polyatomic ions except for ammonium act as non-metals. And so this would be a metal and a non-metal. Now, we never put 2 metals together. So what you're doing is you're recombining them by putting the outsides and the insides together on the other side. Because a metal, if these are going to recombine, the metal would combine with the other non-metal, and the second metal would react with the first non-metal. So that would be our combination. So notice we have AD and then CB. We list the C before the B because you always list the metal first. And so that's a double replacement reaction where you got 2 compounds on both sides. The elements are just trading places is what they're doing there. And let's see, last one is a combustion reaction. Notice this is very specific. It's any number of hydrocarbons, carbons and hydrogens put together. Could be C2H4, could be C3H6. That's why the X and the Y are there. So any number of hydrocarbons combining, and they are forming, anytime something is burning, it's combustion reaction. If a hydrocarbon is burning, it's combining with oxygen and air. Your products are CO2 and H2O. So these things never change in a combustion reaction. The only thing that changes is the actual hydrocarbon that you could have. And then after that, you'd have to balance it. And again, I have the answers to these down here at the bottom. If you want to hit pause, balance the ones at the bottom yourself, and then check what the answers would be, do that. And that's it for today. You have a poll to work on over different types of reactions. So I'll give you more practice on that. So good luck. Actually, I'm back. I forgot I was going to show you how to do some very simple synthesis, decomposition, and combustion reactions. So let me show you how to do that real quick, and we'll be done from there. So a synthesis reaction, remember, it's 2 things come together to form one. When you're looking at real equations, and so how would I complete that? Well, again, it's a metal and a non-metal here. You do have to cross the charges to put them together. Calcium's charge is 2, chlorine's 1. Again, you can get those from the periodic table. Cross the charges, put them together, and you get, because it's a synthesis reaction, those things are coming together, you do have to cross the charges to put them together. Same thing here, you just don't write MgO2 over here. You've got to cross the charges. Magnesium is +2, oxygen's -2. You look them up in the table. Remember, if you can simplify the charges, you do so you don't, and you end up with MgO. Now you might say in this case it's not balanced, but then you have to put them together properly based on their charges. and then balance the equation when you're done. And so that'd be a very simple thing to do, to balance it when you're finished there. I put X's here. You don't have to know how to do the complicated ones this year. Decomposition reaction, same thing. Because we're just dealing with binary compounds this year. We're not going to deal with things that are a little larger than that. So when you're decomposing a binary compound, again, it's two things that break apart. If you're going to break them apart, then it breaks apart into Na and Cl. But remember, again, you have to consider when you write any individual element, does it exist as individual atoms? Almost all the elements on the table do, except for 7 of them. They are the Brinkelhoff elements. Again, Brin, ClHOF. They all exist as diatomic molecules. They don't exist as individual atoms. And again, you'd go, well, it's not balanced. Then you go back and balance it. And so that's how to complete a decomposition reaction, a simple one. Don't worry about the stuff at the bottom. And then the last thing for today is how to complete. And I'm skipping single and double because we're going to spend more time on those the next couple of days. The last thing there is how to finish or complete a combustion reaction. Anytime something is a combustion reaction, in this case, we might just give you this and go, that's a combustion reaction, complete it and balance it. Anytime you have a hydrocarbon that is burning, it is reacting with oxygen, and you're getting CO2 and plus H2O. And then again, this stuff never changes in a combustion reaction. So down here, you know, when you're completing them, you're always getting CO2 plus H2O. You know, CO2 plus H2O, and then you got to balance them from there. So that's how you would complete a combustion reaction. With a hydrocarbon, notice these are all combinations of carbons and hydrogens, even an oxygen there is still a hydrocarbon. Combining with oxygen, produce CO2 and H2O. Now this one down here, you might go, well, it's going to be a little more tougher to balance. It will be, but again, it's still just a combustion reaction. So, like I say, next time we will talk about single and double replacement reactions. So we'll go back to those the next couple of days.